Hi guys, since I am not here in person today, I wanted to go ahead and go over your quiz from last class with you. I will be in class on Thursday, so make sure you have your questions with you when we come back to class. Okay, so as we start looking at this quiz, we have a baseball with a mass of 0.145 kilograms. We know that the velocity of the pitch ball has a magnitude of 30 meters per second. And the ball is batted back with a velocity of 45 meters per second. We want to find the change in momentum of the ball. So the change in momentum is going to be mass times the change in velocity. So if you think about it, initially the ball is going one direction, it hits the bat, and then it starts coming back the other direction. So this is going to be mass times, well, to get the magnitude, we're going to do the absolute value of the change in velocity. So we're going to have negative 45, because it's coming backwards, minus the initial, which is 30, and that's going forward, so that's positive. So it's going to be a negative minus a positive number. So that's going to be the mass, which is 0.145 kilograms, times the magnitude of this is just going to be 75. So when we put that in the random number generator, we have 75 times 0.145. So that's going to be 10.875 units of kilograms meters per second. So it's kilogram times a meter per second. So the magnitude of the impulse applied to the baseball by the bat, the impulse is equal to the change in momentum. So the magnitude of the impulse is going to be the same as the magnitude of the change in momentum. And that's going to be units of Newton seconds. So then we say, okay, if the ball remains in contact for 2 milliseconds, so this is times 10 to the negative third, if you remember our scientific units from earlier, we want to find the magnitude of the average force. So remember that impulse is equal to the force times the change in time. So that means that I'm going to have 10.875 equals the force, I'm not really sure, it's my average force, times 2 times 10 to the negative 3 seconds. So I'm going to take what we had before, divide that by 0.002. I'm going to get that the average force is 5,437.5 newtons. Question 2, we have a frictionless horizontal air table. We have one puck that has a mass of 0.15 kilograms. That is moving towards puck B that has a mass of 0.25 kilograms. That is initially at rest. So if you think about it, you're going to have A coming in with some velocity and hitting B, which is at rest. So that's my initial. So that's before the collision. Then after the collision, puck A has a velocity to the left of 0.120 meters per second. And then puck B has a velocity of 0.650 meters per second to the right. So this is after. We want to know what is the speed of puck A before the collision. So if the net external force is 0, that tells us that momentum is conserved. So that means the momentum we had initial is going to equal to the momentum that we have after the collision. So that means mass of A, velocity of A, plus mass of B velocity of B before the collision is going to equal mass of A times the velocity here, so negative 0.120. We have to take in mind the sign, plus mass of B times 0.650, and this is positive because it is to the right. So if mass of A is 0.150, we're going to be multiplying that by negative 0.120. So this is going to be negative 0.018 here. Mass of B is 0.250. We're multiplying that by 0.650. So this is going to be a positive 0.1625. Now this velocity is 0, so that whole term is going to be 0. So this is going to be 0.150 times the velocity of A. So when I add those two together, 0.18, going to get that this is positive 0.1445. That's going to equal the 0.150 velocity of A. When I divide by that mass, the 0.150, I'm going to get that the velocity of A is just shy of 1 meter per second. It's going to be 0.963 repeating meters per second. Now the last thing we have to do for this is to calculate the change in the kinetic energy of the system that occurs as a result of this collision. So first thing we need to do is we need to look at the initial kinetic energy. So the initial kinetic energy is going to be 1/2 mass times of A times the velocity that we just found squared, because the second part is going to be 0, just because the velocity of B is 0. So this is going to be 1/2 times 0.150 times that 0.963 repeating squared. And when we do that calculation, we get that this is 0.0696, so 0.07 joules. Now if we look at it after, our kinetic after is going to be 1/2 mass of A, the velocity of A after squared, plus 1/2 mass of B, velocity of B after squared. So this is going to be 1/2. The mass of A is 0.150. Velocity of A before, the magnitude, because the sign isn't going to matter, it's squared, 0.120. And we're going to have 1/2. The velocity of B is the mass of B is 0.250. The velocity of B is 0.650. We're going to square that. And so we're going to put all of that into our random number generator. So we're going to have 0.5 times 0.150 times 0.120 quantity squared plus 0.5 times 0.250 times 0.650 quantity squared. So this is going to give us a final kinetic energy of 0.054 joules. When I subtract the initial kinetic energy our change in kinetic energy is negative. We have lost energy. It's going to be negative 0.016 joules. Okay, so for our next problem, we have hockey pucks. Hockey puck B is resting on a smooth ice surface. It's struck by puck A. It's originally traveling at 40 meters per second. That is deflected 30 degrees from the original position. Puck B is going to be going 45 degrees from the original velocity of A. The pucks have the same mass, so we don't get the mass, but we know that it's the same. We want to find the speed of puck A before the collision. So if we come up here, it's right there. If we want to know the speed of puck B before the collision, it's at rest. Now, don't think that it's going to be that easy, because the next thing we have to do is we have to look at the kinetic energy of puck A and puck B before the collision. Well, again, we don't have mass. We just know they have the same mass. So we are going to have that this is the kinetic energy of puck A is going to be 1/2 the mass times velocity of A, quantity squared. The kinetic energy of puck B is going to be just 0 joules because it's at rest. So this is going to be 1/2 times 40 squared, so it's going to be 80 times the mass, and that's going to be in joules. Now, if we want to know the kinetic energy of puck A and puck B after the collision, we need to figure out their velocities after the collision. So what are we going to do? Well, we need to recognize that the momentum in the y direction before is going to equal the momentum in the y direction after. Before, there was nothing in the y direction. So that means we're going to have mass A times velocity of A. This is going to be sine of 30, because that's going to be opposite. So putting theta, let's just go ahead and put 30 in here. Then I've got minus mass of B, velocity of B, sine of 45 degrees. So something I know, the masses are the same, so the masses will cancel out in this problem. 0 divided by any mass is going to be, well, 0. So I've got the velocity of A, sine of 30, so that's 1/2 velocity of A. Sine of 45 is square roots of 2 over 2, velocity of B. So if I did a little bit of multiplication, I could multiply by that 2, and I could get that 0 is equal to velocity of A minus the square root of 2, velocity of B. So that tells me a connection between the two, that the velocity of A is square roots of 2 times the velocity of B. So that gives us our first relation. Then we can look at the momentum in the x direction. So momentum in the x direction before is going to equal the momentum in the x direction after. So what we've got, momentum in the x direction, that's going to be mass of A times that 40 plus mass of B times 0. Then we've got mass of A times velocity of A cosine of 30 degrees. And then I've got plus mass of B, velocity of B cosine of 45 degrees. So again, masses are all going to cancel. So I've got that 40 is going to equal the velocity of A, well, not really sure what that is, but I do have a connection here to velocity of B. So let's go ahead and use that. So that's going to be square roots of 2 times velocity of B. Now cosine of 30 is square roots of 3 over 2. So then here I've got velocity of B. Cosine of 45 is square roots of 2 over 2. So if I take 40 and I multiply it by 2, I'm going to get that 80 is going to equal the square root of 2, 1 plus the square root of 3, velocity of B. So at this point, I'm going to have to go back to my random number generator, and I'm going to have to actually do this numerically. So I'm going to have 80 divided by the square root of 2. Then I'm going to take that answer and I'm going to divide it by 1 plus square root of 3. And I'm going to get that velocity of B is going to be 20.71 meters per second, which means that velocity of A is going to be that times the square root of 2. So that's going to be 29.28 meters per second. So I can go down here now that I have that piece of information, and I could calculate the kinetic energy of puck A and puck B after the collision. So I could do the kinetic energy from A. It's going to be 1/2 mass of A, velocity of A after squared. Kinetic energy of B is going to be 1/2 mass, velocity of B squared. So velocity of A is 29.8. I'm going to square that. I'm going to divide that by 2. So that's going to be about 428.72 times the mass. Okay, I'm going to go back and correct something real quick. Seeing this number here, I realized that I left off a 0 when I was writing this out, because we had 40 squared. 40 squared is 1600, so this should be 800 times the mass. So this should be, let's just write that cleanly, 800 times the mass, not 80. That should be an 800. I dropped a 0 there. So there are times where you work further and you're like, something just doesn't look right. You can go back and you can fix it. So, okay, here for B, we have 1/2, the mass I don't know, velocity of B, so we've got that 20.71, and we're going to square that. So we have 20.71 squared times 0.5. So this is going to be 214.45 times mass, joules. If I add that to my other kinetic energy, that tells me my total kinetic energy after is going to be 643.17 times mass, joules. So if I want to know what fraction of the kinetic energy was dissipated, so how much did we lose? So how much did I lose? I'm going to take 800 minus what I ended up with. I'm going to divide that by the 800. Masses are going to cancel. This is going to tell me it's 0.196. So 19.6% of the kinetic energy is lost. Okay, I'm going to pause here. We're going to do the rest in a second video.